So next week we'll have a professor from CSU Los Angeles talk about analytics, in particular predictive analytics versus some other kinds of analytics. That's next week. Today I have the pleasure of introducing you to Dr. Maya Ackerman from Santa Clara University, who is going to tell us so she will tell us about songwriting helped by computers. So let's welcome her.
Hello everybody. I realized I did not put on my mic. Am I supposed to do something like that? No? Okay, fabulous. Let me know. Can you guys hear me at the back? In case my voice fluctuates and gets too quiet, just let me know. It's a real pleasure to be in a room full of students. I switched jobs this past summer, giving me a 4-month break between school years, if you're considering academia at all. And it's been a while since I spoke to a class of students, so that's wonderful. What year are you in? Somebody was confident what year they're in. What? Senior. That means I'm still in Canadian terms. That's like year 4? Year 4. All right, you guys are finishing up. Computer science department, right? Yeah. Wonderful. I'm super excited to be here. Share some of my work with you. So one of the things I work on is algorithmic songwriting. So I will show you what that is and even show you some songs that we made with the help of a computer. So I got a PhD in computer science at the University of Waterloo. You guys heard of Waterloo? You know, up there with the igloos? Just kidding. Okay. So it was about the middle of my PhD that I started learning how to sing. My husband took some voice lessons. I got super jealous, also took voice lessons. And pretty much spent the latter half of my PhD, in addition, to doing my PhD and doing the research, learning how to sing opera. And sort of developed these 2 parallel lives. On the one part of my life, I became a postdoc and then a professor. And then on another significant part of my life, I was a singer, and I started singing semi-professionally, and that part of my life kept growing. And it was a lot of dissonance. I don't know if any of you have a hobby that means a lot to you. It can be uncomfortable to have your life sort of split. And everything started changing when I attended the International Conference on Computational Creativity. And it was during the very first talk that the speaker mentioned this idea, almost in passing, the idea that a computer doesn't have to be a tool, that it could be a legitimate collaborator. And this idea really had a profound impact on me, because almost instantly I thought, wait, if it can be a collaborator, maybe it can help me write songs. I wanted to write original songs for a long time, and it just wasn't coming to me. Of all the things I can do, writing songs was not one of them. And so I decided that I want to write a computer program that's going to make it possible for me to write songs. It was completely selfish at first, by the way. And it sort of grew from there. So we have a system called Elysium. It's co-created with myself, David Lokar, and my student Christopher Cassian, who joined a few months after the project started. So the 3 of us have been working on this for quite some time. To my genuine surprise, the work has attracted a lot of attention. It's been in the news recently. There was a TV piece on it. That was a lot of fun to make. So the system is data-driven. Do you guys, usually in undergraduate programs, there's not too much machine learning. Do any of you know a little bit about machine learning? Okay, who feels like, okay, that's kind of a bad question. Are there any classes that kind of touch on it a little bit?
AI.
Oh, so you have AI. So did they do a little bit of supervised learning maybe? Yeah. As part of it? Okay, wonderful. How many people took the AI class? There were private lessons in AI. Okay, well that's wonderful that a few of you touched on that a little bit. So by data-driven, and I won't make this, by the way, if you guys want to ask questions, a lot of people wonder why we still meet in classes instead of just learning online. And the reason is that you can raise your hand and ask questions. Have this whole in-person thing happening, so please don't be shy. I like interacting with people, and I know what to cut out so that it won't be talk over too long. Yeah, so but data-driven means that, okay, traditionally, artificial intelligence, at least the original versions of artificial intelligence, were what are called expert systems. Anybody heard that term? Okay, one person. So an expert system is when you basically try to understand how you do something. So if I were a composer, I'd be like, okay, how do I compose music? First, I pick that note. Then I look for something that harmonizes with it. I don't know, some kind of sequence of rules. And then I would code the computer to do exactly what I do. And that would be an expert system. That sort of makes sense? So you can imagine, often expert systems are also applied to medical diagnosis. So a doctor it's very hard to do, but you can imagine a doctor trying very hard to encode all of the rules that they follow. And then there'd be an expert system that would ask you what symptoms you have, blah, 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 and then diagnose you similarly to how a doctor would. That's sort of the old way of doing artificial intelligence, very roughly speaking. More recently, there's this huge wave in artificial intelligence. So in artificial intelligence, we give your computer data. Like in this case, songs. You literally feed in songs. And the computer learns by itself how to make them. Okay? Now, not 100% by itself, because then machine learning would be trivial. But I can make a system that writes songs without knowing how to write songs myself. Which is pretty amazing. So we're letting computers go beyond us. Okay, I don't know if this is necessary. Okay, well, I'll just walk through this quickly. You give them data, then you extract, you kind of point to what's important about the data. So for example, we might tell the machine learning system that the key signature is important. The time signature might be important. That type of stuff. We're not just giving it the data blind in this case. Then it constructs some kind of a model. Then we need to check if what it constructed is any good. If it's not, we repeat the process until we eventually make the model work well. And once the model is built, you can use it in this case to generate music. Okay, I won't dwell on it because I think it's a little bit much. I will actually skip a whole bunch of this. So once your model comes out, let me sort of explain to you a little bit more how my particular system works. So you give it text. So let's say any line of text. Today is a nice day, that's it, right? And eventually it's going to output some melodies. So like, today is a nice day, today is a nice day. You know, various ways you could sing that one line. What it does underneath it actually tries to predict the next line. It tries to guess what the next note is. Okay, so it's a prediction model underneath it all, and it has a certain accuracy. I'm going to skip through some of this to not bore you guys. And we can go back to the details of how it works if you guys are interested. So we had this professor from CSU Long Beach, Joshua Palki, who used the system, who used Elysium to make a song. And then most recently, we added some co-created functionality. So for example, let's say you like one of the melodies that Elysium creates, but it's not exactly what you want to settle on. You want something similar. So you can specify that. Or you can say, I like the rhythm, but I don't like the notes that you pick. Like, I like how long the notes are, but not exactly what they are. So you can indicate that as well. Okay, I need somebody to ask a question. I'm feeling like I'm talking to myself. You guys follow, sort of? Yeah?
So by data in AI, we hear about like neural networks a lot. Is that kind of what the data part of the timeline is?
So you want, oh, very good question. There we go, that was an awesome question. Okay, so a neural network is a model. Right? So originally we used what are called random forests. You guys learned decision trees somewhere? Okay, so a random forest is just a whole bunch of decision trees where they all take a vote, and that's how you decide what to do. Okay, so originally we used decision tree because we had very little data. But actually most recently we got this data set of hundreds of thousands of songs. And so we were able to run it on a neural network, apply some deep learning, all of this sophisticated stuff. It's actually really amazing what can be done with neural nets. So there's this point over here where I said that you need to tell the computer what's important, identify the features. With deep neural nets, you can actually skip this step. It really does this amazing job simulating the way that humans actually learn. It figures out by itself what's important and what's not.
How large of a training set did you need for something like this?
So it's a very good question. And generally speaking, when you're talking about neural networks, you need a lot of data. So for our neural net example, it's hundreds of thousands of songs. But actually, the songs that I'm going to show you that we made here were trained on about 30 songs. So there are cases where you can do really well on very little amount of data. And there was actually this one time where we just wanted to see what would happen if we trained it on 3, 5 songs, just to see how it would go. And what ends up happening is that it imitates the style really well. Right? So it actually sounds good, right? Because if you're mimicking a really well-defined style, then it's probably going to sound like that style and sound reasonably good. But then the system is not really being original. It doesn't really have its own style, so it's a bit of a trade-off. So that's interesting to keep in mind, that for some applications, it's okay to have a fairly small data set and still do something, whereas others, you can't, and it really depends what you pick here. So stuff like random forest is good for small data sets. I'm actually teaching a machine learning class coming up in 1 week. Good practice for me. Any more questions actually about how it works? Or maybe we could go back to that if you guys get curious.
You mentioned that the parts in this decision tree take a vote. What influences that vote?
So, okay, so
Would it just be the features that you pick out, or?
So exactly, yeah. So each tree is trained on a small subset of features. So really, there are a lot of different features here. In our system, for example, when you're trying to predict the next note, you're given information about the previous 5 notes, their duration, how important, how rare are the words. There's lots and lots of different features. So each tree has a random subset of features, and it sort of builds a decision tree based on that. And then they take a vote when it's time to predict the next note. Take a vote, take a majority vote. Yeah, and that's a random forest. It's very elegant, actually, and it's not that complicated. Yeah. Yeah. So if you guys want to kind of get started in machine learning and you feel intimidated, random forests are actually kind of a nice place to get started. And then evaluation is really important. The way evaluation works is that we measure how many times it correctly predicted the next note on another data set. So we train it on some songs, and then we give it some other songs on which we check how well it does on prediction. Okay. We can always rewind back to that if you guys get curious. Yeah, so it can be applied for different genres. We tried to create pop music, and we tried to create classical music. It's been a lot of fun. Okay, I want to show you one of the songs. And I have this dilemma if I should attempt to sing it, because I've sort of had a cold the past week. But I sort of want to try. You guys seem friendly.
Do it.
If it gets really bad, I'm just going to stop and play the recording, okay? As long as you guys are okay with that. I'm scared. I haven't sang this. Okay, we use Emily Dickinson poetry. Do you guys know Emily Dickinson? Yeah, she's really cryptic language, cute poetry. So we decided. So in our system, we have to feed the text, right? So that's the text we get. And of course, we still needed somebody to arrange it, and to sing it, and produce it. And so people did end up helping in various ways. Do you guys feel like you understand the process of using the system? Type lyrics, it gives you options for melodies for those lyrics. That was a computer's problem. Okay, let's make sure it's loud enough. Is this okay?
And sings unto
guys. To be honest, not quite as good as usual, but I managed to sing. So I'm going to skip the one that has the vocals on it. Okay, so then, okay, this part I could explain without assuming too much machine learning knowledge. Okay, so within computational creativity and artificial intelligence in general, it's considered relatively easy to have a system generate stuff. You know how computers are much faster than us in a lot of things? So they can actually create, so imagine like you're trying to write a poem with a computer. You could just have it try random characters in principle, right? And eventually it could create something great. Right? This is kind of sort of the extreme case. At least it doesn't work like that. It's not random. But generating is relatively easy for a computer if you don't care about the quality of what's being generated. That makes sense intuitively? There's a story about the Library of Babel where you had every single book that up to 300 and something pages, and every single one has ever been written and will ever be written, but that includes all the random strings of characters. Right, so it's useless. So the real challenge is to have your artificial intelligence evaluate what it creates. So you know how an artist can create a painting and then throw it out? Or like authors keep tossing out papers that they've written because then they decide it's terrible. So we want artificial intelligence to be the same thing. To not only generate, but by itself decide how good it is. Okay? And so Elysium can do that. It's its own critic. So the way that we do it is it's a balance between entropy and likelihood, which are sort of super fancy words, but they don't mean anything complicated. Likelihood means how likely that sequence was to be generated. So do you know how sometimes you say something, and even though you said it, you weren't very likely to say it? Let's say you are feeling really angry and you tell your girlfriend or boyfriend something that you're like, how could I say something like that? So Elysium can do that too. It can create melodies that it wasn't likely to create. That make sense? Right, so we just check the probability later. There's a simple mathematical way to check the probability that that sequence was generated. And generally speaking, we prefer more likely sequences. Right, we prefer melodies that Elysium was likely to generate. Except for this one problem, entropy. Entropy says how much variety there is in the melody. Any of you ever notice how repetitive pop songs are? Not only in lyrics, but there's actually a lot of musical phrases that use exactly the same note, using exactly the same duration. Seriously, it's crazy. It's like these singers just sing on the same note for like 2 sentences. And so we originally trained Elysium on pop music. And so Elysium often produced melodies that were super boring. It just keeps repeating the same note. And we were asking ourselves, what is happening? And then we understood it's because of the training set. Make sense? So anything silly you find in your training set, your system might do as well. And so we started penalizing melodies that were very, very repetitive. Because even if pop song includes these melodies, if you're a person trying to make a song, it wouldn't help you if Elysium gives you this type of melodies, because you can come up with them by yourself, even with zero musical experience. Just repeat the same note. Yeah, so the measure of quality is a combination of these two, and it's just a mathematical formula that you can apply to the value. Okay, I'm going to skip this song because I want to. Actually, do you guys want to hear another one? I mean, it's just a recording. I'll do like the first verse. Okay, and then it repeats. Okay. Anyway, so there were a couple of examples. So another work that I wanted to tell you about. Oh, any questions about Elysium, by the way? Yeah.
So is the rhythm of the melody extracted from the lyrics, or is it something you have to add in yourself?
So it gives you complete melody. So it gives you, is there anywhere I can draw? Are there pens? I can probably explain it. It gives you the complete melody score with the notes, with like the pitch value and the duration. Yeah, let's, I'm not great at catching. So you type something like, this is nice. What's it to? I need something with 2 syllables. More. Okay. So what it ends up doing, it ends up assigning a note per syllable. Nice is 1 syllable, or name. Okay. So it's going to give you a whole bunch of options. They're going to look something like this. We have our musical score. Well, if it's right, I'm going to draw the wrong little lines. And then it's going to do something like maybe this here. This. By the way, if any of you are interested, I'm going to have the system come out, be available online soon. If you guys tell me that you're interested, I'll just send you a link to it when it's available. Although, you know, it might be buggy, so you got to be patient with it. Should still be very usable though. Okay, so let's say this will be a quarter note, this will be a whole note, this will be 8 notes, and this is. So that's the kind of output it gives you. That's the input, and that's the output, and it can give you as many outputs as you're willing to look at. Now what it does is it sorts its outputs by quality. So it gives you the stuff that it thinks is best at first, and then the next stuff. And typically, I like one of its first 3 suggestions. I felt like there were more questions. Yeah.
Does it handle the dynamics, so like crescendos, decrescendos? all
No,
that
no,
kind
it
of stuff?
doesn't. But we could add that in. That would not be. I don't want to say it'd be easy, but it's definitely well within the scope to add that in. Very good question. Yeah.
So Elysium doesn't actually like write the music, it just sort of figures out what would be the best optimal notes to be playing at that syllable.
That's right. So it doesn't have accompaniment. It doesn't like compose the music.
So there's like a guy that actually makes the music on.
So there's a lot that humans are still doing. That's
Okay.
right. That's right. So it's not. I mean, music is once you kind of look into songwriting, it's really pretty crazy how much you have to be able to do to create one song. I don't know, how many of you here make music? Okay, a few people hesitate. Okay, so some of you have a little bit of experience with that. So you need to be able to produce, which luckily is not too hard today on the computer, but it's still a skill to do it well. It's far from easy. And then you need to be able to sing, or have somebody who can sing. And then you need to be able to write lyrics. You need to be able to come up with melodies for these lyrics. Then you need to be able to arrange it into like a nice arrangement, have chords underneath or something more complicated underneath. It's really a lot of sort of disjoint skills. And Elysium does one of them. Yeah, it does one well-defined role. You give it lyrics, it can help you come up with melodies. Yeah. Now that's the part that I struggled with most. There are other people for whom other parts of the process are very difficult, like coming up with lyrics. Some people are better at doing that. So ideally, you'd have AI tools filling in whatever you find most difficult. And that would let you focus on the parts that you enjoy most. So that's sort of the vision here. Final question about Elysium before I move on? Yeah.
So you mentioned that the data set obviously is very important. In the pop songs, there's like the same couple of notes that happen again and again.
Like 5 or 6 in a row.
Yeah, it's terrifying once you know. But you also mentioned you train also on classical music as well. Did you also evaluate on other different kinds of genres and find different characteristics about them that popped up while working with Elysium?
A little bit. So that observation about pop was definitely the most shocking for me. But we also trained on Puccini music, which I'll show you. I'll show you some stuff we made of that. So Italian arias, and we created, I have my colleague who's not a musician, who's never read the music before, he used it to create really pleasing arias, which is amazing, I think. But I was also surprised to see that even in Puccini music, you have these sequences of repeated notes, which I was not, I mean, I sang opera and I didn't notice that somehow, because they're so well placed. But when you're doing a co-creative system, you need to think what kind of stuff will be helpful for the user. So it's, So direct imitation doesn't always work. Okay, so let me show you this other one. This is cool too. And if you guys want to ask more questions about Elysium later, that will also be fine. Okay, by the way, for those of you who do want to get in touch with me later, if you're curious, it's just Maya Ackerman. I'm easily Googleable, or mayaackerman.info. Really trivial to find. One time, this car salesperson said he couldn't get in touch with me. How can you not get in touch with me? Okay, so we created another system called Mabel. I like to call my systems after girls' names to increase the number of women in computer science. It's a joke, right? At one time, I once people actually clapped to that. I never quite understood that. Anyways, there is this other system called Mexica by my colleague in Mexico, who I'm going to see in a few weeks. So excited. So he has a system that writes narratives. Now, coming up with coherent stories, actually with coherent anything, is notoriously difficult for a computer. So if you want to create text that sort of looks like text, and then puts together sentences in a grammatically correct way, no problem. A ton of methods out there. But if you want a coherent story that makes sense, that's really hard. And so he solved it for a very specific domain. His system writes stories, reasonably interesting ones, about the Mexicas, who are the indigenous people of Mexico City. And here's an example of the kind of stories that his system writes. Okay, I'm going to read it for you. The priest was born under grace of the great God. The lady was an inhabitant of the great city. The lady wanted him from the start. Not subtle stories. Okay? The lady hid her love from the priest, but she fell in love with him. The princess was in love with the prince. The princess admired the lady, so we're kind of working here towards a love triangle, intentionally. And I'll cut it off there. But basically, people often die, stuff like that. Really interesting narratives. So we started off with his system, which we already had, and we extended it into lyrics. Okay, and that way we were able to create coherent lyrics that tell stories, which was never done before. There's a whole bunch of lyric systems out there, some of which I really admire because they're beautiful, but they all sound like really sophisticated, but you're not sure what they're talking about. And the truth is that the system also doesn't know what it's talking about. Right? Do you know how like sometimes somebody talks to you and they use really fancy language, so you just assume they know what they're talking about? With computers, it's very easy to create that illusion. Well, not very easy, I should not exaggerate. But it's possible to create that illusion, right? So it makes it so humans will believe there's something there, but not understand what it is. So we wanted to create something that's actually there, so humans will be able to follow our story. We wanted to write lyrics that people could enjoy in this, while comprehending. Okay, so what our system does is it keeps the whole story, but it adds these red lines, kind of interleaves these new lines. So we get this kind of lyrics here. The priest was born under grace of the great God, and evolving from the shadows lifted. So it's not really clear what it means by itself, but altogether it sort of works. The lady was an inhabitant of the great city, and just remember there's a sign of intensity. Okay. The lady wanted him from the start. The friends said they are, so I was very happy with that. So I go, this sort of makes sense. Now they're friends. Yeah. The lady hid her love from the priest. Just think they got a secret. Huh? This kind of works. Seems like it knows what it's talking about. So we do some stuff in the background to try to make it make sense. But a lot of it does rely on humans being willing to fill in some gaps. But she fell in love with him. They don't know the time. The princess was in love with the priest, wondering where they have got. Okay, this one's kind of a rough one. The princess admired the lady. Movies only. They get kind of some fun stuff. So we really enjoyed that. We presented this paper at a conference a few months ago, and me and Raphael, he was on the guitar and I sang it during the conference. We had a blast. But there's a lot of work stuff to be done. Right? We're kind of on the right track. So one thing that I wanted to look at is go back to the co-creative model. So in general, in computational creativity, it's one of the things I'd like you to get out of the talk today. There's sort of two main tracks. One is to have the computer do stuff by itself. So this thing that I just showed you, the computer did by itself without human interference. I mean, the humans interfered in coding the computer, but then you just press a button and this happens, okay? The other track is co-creativity, so having the computer be a collaborator. So these two things have sort of separate goals. So we made this poem using a co-creative variation where we fed in every other line, and then we got some options for Elysia, for Mabel's line, and we selected amongst them. So kind of more of an Elysia model here. So we typed this, then the system suggested options for here. We picked the ones we like, and that way we keep going. So that way we were able to get things that are much higher quality, but that nevertheless make it easier to compose lyrics. Beautiful memory, it was always you, wishing you were back, thinking of only you. That's what we fed it. I just made it up in about 2 minutes. And then we created the song. I can try to sing it if you want, because I don't have a recording. And then we fed it into Elysia. So it's sort of like one system was used for the lyrics, and another system was used for the lyrics and melody. We're done separately. Let me see if I can do it. A beautiful memory, all my life story. It was always you to make things new. Wishing you were back, but I can't stop thinking of only you. Could I make it through? A beautiful memory, it could make me crazy. It was always you, try as I do. Wishing you were back, but I can't think, thinking of only you. I was torn in two, a beautiful memory. We don't need no money, it was always you. Take me to you. Wishing you were back, but I can't think, thinking of only you. If I could love you. I need to do a cappella from now on. Who needs music? Yeah, so I was actually pretty happy with this one. You know, when there is I think it's actually one of my favorites that we've made so far, and it's both the music and the words were partially created by machine. All right, any questions about Mabel? We have 5 minutes, right?
5 minutes.
Maybe 6. 6 minutes, all right, plenty of time. Any questions? Wait, then I'll show you one more thing. There's time for questions.
Does it automatically do the rhyming, or do you
So it does it right. Yeah. So the lines that it does are unaltered. Same with Elysia. Once we got Elysia good enough, we stopped having to modify like that. At first, I had to modify the lines that we were training. Yeah, so every other line is Mabel. And we're working towards improving those systems as well. Okay, Roboccini, that's the stuff. Giacomo Puccini, famous Italian opera writer, composer, wonderful guy, writes beautiful stuff. So we trained Elysia on Puccini music, so we called the system Roboccini, breaking my rule of giving my systems female names. And my colleague James Morgan, also known as Rabbi Yacht, he's an artist, used the system to create this aria without being a musician, without having any musical training. So I think that really gives credence to what we're doing here, being effective. Again, somebody had to produce the music and sing it, me, of course. Yeah. So these are it's the English words, we're then translated into Italian. It tells a story of a torrent who lives in World of Warcraft, a female torrent. I once performed the song with torrents at a conference. It was awesome. So the torrent, is a very important character, right? And so a lot of her friends and co-workers want her to join on raids, but she wants to settle down and have a family, right? Like any normal torrent. And sort of the song, this whole opera which we're working on, but the song in particular kind of starts to hint at some of these challenges that she's facing. Yeah, I could not make it up. James Morgan is really incredible. So just quickly, the English. Lush oases that hide the wailing caverns, vast open spaces of oranges and gold, the grasses of the prairie, the wandering lizards, setting the scene. I've made a home and made a family in the south on an outpost with a small community that sees such traffic as the passing adventurers. So this starts to hint at some kind of mixed feelings about being pulled into this adventurer role. So, ready. The melody was made with drum machine. That's my character. Grants PhDs, so I'm not trying to, to push that, but I thought it's worth mentioning. All right, this was great. I really miss hanging out with students. Thanks for reminding me of that slide.